Good morning, students. So the last chapter matrix is completed. Now today can be discussed some new chapter, determinants. So determinant, it's also one part of matrices. So ಈಗ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನು ಓದಿದ್ದೀರ ಅದ್ರ ಮೇಲೇ ಡಿಟರ್ಮಿನೆಂಟ್ಸು ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಫೇಲ್ ವಾಟ್ ಅಬೌಟ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್. ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ಅಂದರೆ ಏನು ನೋಡಿ. ಸೊ ಎವ್ರಿ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಎ ಈಕ್ವಲ್ಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಎ ಆರ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಎ ಐ ಜೆ of order n. Order n means order of the matrix is n cross n. Number of rows and number of columns are n. We can associate a number. So it means called as a single number. So every elements of the matrix are associated in a number is called the determinant of a square matrix. But in any one of the square matrix which contains some different types of elements, either it will be real or it will be complex. So for example, A is one of the matrix of order 2 cross 2. Elements are in the form of 2, 3, 1, minus 1. So how many elements are will be there in that matrix? So 4 different elements are will be there. These elements are associate a single number. ಎಲ್ಲ ನಮ್ಮ ಎಲಿಮೆಂಟ್ಸ್ಗಳನ್ನ ಸೇರಿಸಿ ಒಂದು ಸಿಂಗಲ್ ನಂಬರ್ಸ್ ಮಾಡೋದನ್ನು ವಿಲ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ಆಫ್ ಎ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಬಟ್ ಇನ್ ಎನಿ ಡಿಟರ್ಮಿನೆಂಟ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸಿಸ್ಟ್ ಓನ್ಲಿ ಇನ್ ಎ square matrix. Either it will be 2 cross 2 matrix, otherwise it will be 3 cross 3 matrix. So now elements of that matrix means values of that matrix or numbers of the matrix are denoted by. So that is a definition of the determinants. So every square matrix A is equal to Aij of order n. We can associate a number is called the determinant of a square matrix. It's one of the definition. But the value or number of the determinant is denoted by using the symbol. One of them is det of A, means determinant of A is one of the short form of the word. So determinants purti word alli it's one of the short form. Otherwise it's also denoted by using that symbol. Now it's generally is called as modulus anta karitivi, but in this chapter it's not for modulus, it's called as determinants. So modulus lines is called as determinants of A. It's particularly only for this chapter, determinant of A. Otherwise it's also called as, its another symbol is delta. These are the denoted symbol what are will be called as values of the determinants. Value of the determinants are denoted by using the symbol det of A, otherwise determinant of A, otherwise delta. Next way, how to can be solving the values are numbers of the delta by using some of the square matrix. Now the first one is matrix of order 1, means if any given matrix are in there 1 cross 1 matrix. Generally elements of the matrix can be written as single element is denoted for A, but such an element is not particularly denoted for A11, A12, A13 like this, because it's one of the single elements. It's not sufficiently denoted for in which column or in which rows. Generally it can be written as A. Now the determinant values can be denoted by either in any one of these symbols. Values of the determinant is denoted by either det of A, otherwise determinant of A, otherwise delta. Is denoted by is one of the modulus line, it will be equal to A. Means whatever the elements of the matrix A is also called as value of the determinant such a matrix of order 1 cross 1. Similarly, second one is matrix of order 2 cross 2. So what are the elements of the matrix of order 2 cross 2? Now let A is one of the matrix of order 2 cross 2, whose elements are generally can be written as A11, A12, A13 or A21, A22. Elements of A are A11, A12, A21, A22. It's a 2 cross 2 matrix. Then how to get solving the values of the determinant. Again, if it is denoted by either in modulus of A, otherwise delta, otherwise determinant of A. And these elements are also enclosed in a determinant lines. Such a line is called as determinant line, not for the modulus. So now the elements of the matrix are enclosed by using in the square matrix or in the simple bracket, but the elements of the determinants are enclosed by using the determinant lines A11, A12, A21, A22. These are the elements of the determinant. So then get simplify. This implies what are will be called as principal diagonal elements or left diagonal elements. Now in the elements of the square matrix, some of their elements are called as diagonal elements or principal diagonal elements. These are also called as left diagonal elements, and other ways are called as right diagonal elements. Then the product of left diagonal minus product of right diagonals. Product of left diagonal minus product of right diagonal. This implies A11 into A22. A11 into A22 minus A21. A21 into A12. A12. So that is the value or number of the delta or determinant. So which can be associate one of the single number. So what are the examples of the determinants? Given one example how to find the values of the determinants by using 2 cross 2 matrix. Let A is equal to 1, 2, 3, 4. It's one of the 2 cross 2 matrix. Then delta A or determinant of A can be written as by using the determinant lines 1, 2, 3, 4. So after that get multiply. First we'll multiply what are the elements are called as left diagonal. So left diagonal is 1 into 4. So 1 into 4 is nothing but 4 minus again product of the right diagonals. Right diagonals are nothing but 3 into 2. 3 into 2 is 6. That is 4 minus 6 is equal to minus 2. Then such a value is called as value of the determinant. So similarly, it's another one of the example. Let A is equal to 0 minus 2, 1, 5. 0 minus 2, 1, 5. Then determinant of A is equal to determinant of 0 minus 2, 1, 5. This implies again what are will be called as diagonal elements. Now the first diagonals are 0 and 5. What about their product? 0 into 5 is 0 minus. Now what are will be called as right diagonals? Minus 2 into 1. Then their product is minus 2. And according to the definitions of multiplication of 2 cross 2 matrix, product of left diagonal minus right diagonals, between of them is represented for some of the negative value. So by using that negative values between of these two products, and one of the negative values in their given elements, 1 into minus 2 is nothing but minus 2. That is 0 minus of minus 2. It can be written as plus 2. So that is one of the value for the determinant. So that is one of the method of simplification for the matrix of order 2 cross 2. Suppose if the given matrix of order 1 cross 1, which of the elements of the given matrix is one of the value for the determinant. But in case of 2 cross 2 matrix, so elements can be represented in the form of determinant. So first we'll multiply the what are will be called as left diagonal minus elements of the right diagonal. Left diagonal minus right diagonal. So given an example of these two cross 2 matrices. So next we'll discuss with 3 cross 3. We'll see. Next one, matrix of order 3 cross 3. Now, generally, elements of the matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33. These are the elements of the matrix of order 3 cross 3. Now, total number of elements of the matrix is 9. So, if all these 9 elements are associated in a single number is called as values of the determinant. So, first will these 3 cross 3 elements can be reduced or associated in the form of 2 cross 2. So, we will already discuss with how to get simplify the elements of the determinants in 2 cross 2 matrix. ಈ 2 cross 2 matrix ಎಲಿಮೆಂಟ್ನ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡೋದು ಅಥವಾ ವ್ಯಾಲ್ಯೂ ಸಾಲ್ವ್ ಮಾಡೋದು ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಸೊ 3 cross 3 matrix is also associate in the form of 2 cross 2. But if the associates of these numbers are multiplied by some positive and negative of alternating sign. So, each elements are multiplied by -1 whole to the power of I plus j. So, each elements of the matrix of order 3 cross 3, it's multiplied by -1 whole to the power of I plus j, where I and j are the sufficient rows and columns of the given matrix. So, in the first element A11, so 1 and 1 are represented for in which rows and which column? These are the values of I and j. Therefore, the sign of the 3 cross 3 matrix, in the first element I is nothing but 1 and j is nothing but 1. 1 plus 1 is 2, -1 whole to the power of 2 is nothing but positive. Similarly, in the second element A12, so 1 is nothing but I and j is nothing but 2, 1 plus 2 is 3, 1 minus 1 whole to the power of 3 is nothing but minus. Similarly, A13, so I is equal to 1, j is equal to 3, 1 plus 3 is 4, minus 1 whole to the power of 4 is nothing but positive. Similarly, so we will come to the second row. So, A21, I is equal to 2, j is equal to 1. So, 2 plus 1 is 3, minus 1 whole to the power of 3 means negative. Next element A22, so I is equal to 2, j is equal to 2, 2 plus 2 is 4, minus 1 whole to the power of 4 is nothing but positive. Therefore, the next element is multiplied by positive. And the last element A23, I is equal to 2, j is equal to 3, 2 plus 3 is 5, minus 1 whole to the power of 5 is negative, minus 1 whole to the power of 5 is minus. Then third row, A31, I is equal to 3, j is equal to 1, 3 plus 1 is 4, minus 1 whole to the power of 4 is nothing but positive. Therefore, such an element is multiplied by plus. A32, I is 3, j is 2, 3 plus 2 is 5, minus 1 whole to the power of 5 is nothing but negative. And last element A33, I is 3, j is 3, therefore minus 1 whole to the power of 3 plus 3 is 6, therefore it's get multiplied by positive. Now these will be called as sign of the 9 elements of the 3 cross 3 matrix. So, in the first row plus minus plus, and in second row negative positive negative, minus plus minus, and in third row plus minus plus. Similarly, it also can be read as in the column wise. First column plus minus plus, minus plus minus, plus minus plus. So, what about an application of these determinants? But in any 3 cross 3 matrix can be associate or expand in terms of 2 cross 2 determinant. 3 cross 3 determinant na expand ಮಾಡಬೇಕು in terms of 2 cross 2 ಗೆ. But 2 cross 2 expand ಮಾಡಬೇಕಾದ್ರೆ if these symbols are get multiplied in elements of that matrix. Now it can be expand using in any row or any columns. 3 rows and 3 columns ಅಲ್ಲಿ in any one of the rows or in any one of the columns can be using by using their expansion of the 3 cross 3 matrix. So first will in which of the rows are will be using, ನೀವು ಯಾವ ರೋನ ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀರ ಅದರದ್ದು ಸಿಂಬಲ್ಸ್ಗಳನ್ನ ಮಾತ್ರ ನಾವಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಓನ್ಲಿ ಫಾರ್ ದಿ ಫಸ್ಟ್ ರೋ, ನಾನು ಫಸ್ಟ್ ರೋ ಡಿಪೆಂಡ್ ಮಾಡಿ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿದ್ರೆ ದಿ ಸಿಂಬಲ್ಸ್ ಆರ್ ಗೆಟ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಇನ್ ದರ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ರೋ. Otherwise, suppose if it is can be expand by using the first column, what are the symbols of the first column can be using in this expansion. Similarly, for the third row ನಾನು ಯೂಸ್ ಮಾಡ್ತೀನಿ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡ್ತೀನಿ ಅನ್ನೋದಾದರೆ what are the symbols are using in the third row. So therefore, these symbols are get multiplied in which of the rows are using the expansion of the matrices. So ನಾನು ಇವಾಗ 2 types of expansion explain ಮಾಡ್ತೀನಿ. So after that in any one of them will be following with. So first now delta A or determinant of A can be written as determinant of A11, A12, A13, A21, A22, A23 and A31, A32, A33. These elements of the matrix of order 3 cross 3 can be expanded by using the form of determinant. Now first by using expansion along ಫಸ್ಟ್ ರೋ, ನಾನು ಯೂಸ್ ಮಾಡ್ತಾ ಇರೋದು ಫಸ್ಟ್ ರೋನ ಯೂಸ್ ಮಾಡಿ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ದೇರ್ಫೋರ್ ವಾಟ್ ಆರ್ ದಿ ಸಿಂಬಲ್ಸ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ರೋ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಆರ್ ಗೆಟ್ ಮಲ್ಟಿಪ್ಲೈ ದ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ರೋ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್. So suppose if it can be expanded by using the second row, these are denoted by minus plus minus. As in third row plus minus plus. Similarly for the column wise, in first column plus minus plus, second column is minus plus minus, and in third column is plus minus plus. After that, in the first element, plus into A11 can be written as A11, means these symbols are multiplied by the corresponding elements of the first row. First row element in a jotege, these symbols are get multiplied. A11 into plus can be written as A11. Now A11 is the element of first row and first column. A11 is the element of first row and first column. These elements are get neglected. Correctly observe my fingers. ನನ್ನ ಕೈನ ನೀಟಾಗಿ ನೋಡಿ ಅಲ್ಲಿ. ಸೊ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಇತ್ತು ಆ ಎಲಿಮೆಂಟ್ಸ್ ಇರೋ ರೋಸ್ ಆ್ಯಂಡ್ ಕಾಲಮ್ಸ್ನ ನಾನು ಕ್ಲೋಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಗೆಟ್ ನೆಗ್ಲೆಕ್ಟೆಡ್, ಅವುಗಳನ್ನ ಬಿಟ್ಬಿಡಿ. ವಾಟ್ ಅಬೌಟ್ ದ ರಿಮೈನಿಂಗ್ಸ್? ಸೊ ವಾಟ್ ಆರ್ ವಿಲ್ ಬಿ ರಿಮೈನಿಂಗ್ ಆಫ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್? A22, A23, A32, A33. These are the elements of 2 cross 2. A22, A23, A32, A33. We'll observe them. That is one of the 2 cross 2 determinants. So that is called as expansion of the 3 cross 3 matrices in terms of 2 cross 2 determinants. So now again once we'll observe them. A11 is the element of the first row and first column. These elements are get neglected. ಸೊ ನಾನು ಏನು ಕ್ಲೋಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ ಅದಷ್ಟು ಎಲಿಮೆಂಟ್ಸನ್ನು ಬಿಟ್ಬಿಡಿ. ಸೊ ವಾಟ್ ಆರ್ ವಿಲ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ರಿಮೈನಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್. ನಮಗೆ ಈಗೇನು ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ಲಿ, ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ವಿಲ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಇನ್ ದ 2 cross 2 determinants can be using these elements. Similarly, continuing. Next element is minus. Minus A12. Suppose if the elements is already containing some negative values in the given problem, minus into minus is nothing but positive. So ನಿಮ್ಮ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೇ ಒಂದು ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ದರೆ these two are get multiplied with each other. But if it is positive, plus into minus is minus. Second element is A12. Second one is A12. Now A12 is an element of first row and second column. A12 is an element of first row and second column. Again these elements are get neglected. These elements, what are the closing of these rows and columns? ನಾನು ಯಾವ ರೋನ ಮತ್ತು ಕಾಲಮ್ಸ್ನ ಕ್ಲೋಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. These elements are get neglected. So what are the remainings? A12, A21, A23, A31, A33. So these are the elements of A21, A23, A31, A33. These are the another one 2 cross 2 determinant. Now come to the third row. So third row is nothing but third element is A13. It's multiplied by plus. That is plus A13 of. Again A13 is an element of first row and third column. A13 is an element of first row, third column, and again these elements are get neglected. What are the elements of first row and third columns are get neglected, and the remaining elements are A21, A22, A31, A32. A21, A22, A31, A32. So that is 3 cross 3 determinant can be expanded in terms of 2 cross 2. So after that, by using the condition of 2 cross 2 determinants, we'll already discuss how to get simplify in 2 cross 2 determinants. We'll already know that. By using that procedure, if it is get simplified. Now the first element is A11. So A11 of. So what are the condition of 2 cross 2 determinants? So product of left diagonal minus right diagonals. What are the elements of product of left diagonal minus right diagonal? So left diagonals are A22, A33, A22, A33 minus A23, A32. That is first one. Similarly, minus A12 of. A12 of product of left diagonals are A21, A33 minus A23, A31. Then last element A13 of. A13 of. Again product of left diagonals. Left diagonals are A21, A32 minus A22 into A31. So after that, it's again get simplified, means get multiplied, distribution by using A11. So A11, A22, A33, that is the first element, minus A11, A23, A32. Similarly, second group is also distributed by using minus A12. So minus A12 into A21, A33. After that, minus into minus is plus. A12, A23, A31. Third group, plus A13, A21, A32. Minus A13, A22, A31. So these elements are called as an equation 1. But if that values are called as, after simplification, outer values are will be exist, that is called as one of the value of the determinant. But it's one of the method. So now it can be using their expansion of first row. So ನಾವು ಯಾವ್ದಾದ್ರು ಒಂದು ರೋ ಅಥವಾ ಒಂದು ಕಾಲಮ್ಸ್ ಮೇಲೆ ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಆಗ ನಾನು ಈಗ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರೋದು ಓನ್ಲಿ ಫಸ್ಟ್ ರೋ. ಸಿಮಿಲರ್ಲಿ ಅದೇ ಥರ ನಾನು ಐದರ್ ಇನ್ ಫಸ್ಟ್ ಕಾಲಮ್ ಆರ್ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಆರ್ ಥರ್ಡ್ ಕಾಲಮ್ ಆರ್ ಸೆಕೆಂಡ್ ರೋ ಆರ್ ಥರ್ಡ್ ರೋನ ಯೂಸ್ ಮಾಡಿನೂ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಟ್ಸ್ ಅನದರ್ ಒನ್ ಕ್ಯಾನ್ ಬಿ ಸಿಂಪ್ಲಿಫೈ ಯೂಸಿಂಗ್ ಸೆಕೆಂಡ್. ಈಗ ಅದೇ ಪ್ರಾಬ್ಲಮ್ನ ಸೆಕೆಂಡ್ ರೋನಲ್ಲಿ ಯೂಸ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ಮೇಲೂ ಸೇಮ್ ಆನ್ಸರ್ ಬರಬೇಕು ನನಗೆ. ಅದನ್ನು ಒಂದು ಸಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಚೆಕ್ ಮಾಡೋಣ. ಸೊ ವಿಲ್ ಅಬ್ಸರ್ವ್ ದೀಸ್ ಸಿಂಬಲ್ಸ್. ಬಟ್ ಇನ್ ಸೆಕೆಂಡ್ ರೋ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಗೆಟ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಮೈನಸ್ ಪ್ಲಸ್ ಮೈನಸ್. ಫಸ್ಟ್ ರೋ ಆಗಿರೋದ್ರಿಂದ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ಸಿಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಇನ್ ಸೆಕೆಂಡ್ ರೋ ದೀಸ್ ಆರ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಮೈನಸ್ ಪ್ಲಸ್ ಮೈನಸ್. Now first we'll write the determinant of A. Elements are A11, A12, A13, A21, A22, A23, A31, A3 to A33. So now we'll consider what are the elements of the second row, or it's also by using some another columns, either in second column or in third column, any one can be using in their expansion. Now it can be expand by using second row, means R2. So therefore symbols of R2s are nothing but minus plus minus. Symbols of second rows are nothing but minus plus minus. Get simplified. What are the elements of the values of determinant of A equals? In the first elements are multiplied by minus A21 of. So how to get expand the 3 cross 3 determinants in terms of 2 cross 2. Again A21 is an element of first column second row. It's an element of first column second row. Therefore these elements are get neglected. So what are the elements of first column second rows are get neglected. Remainings are nothing but A12, A13, A32, A33. Similarly second element is A22. It's get multiplied by plus, that is plus A22 of. Again A22 is an element of second row second column. A22 is an element of second row second column. Again these elements are get neglected. What are the elements of second row and second columns are get neglected? So what are the remaining? Second row second column is get neglected. Remainings are A11, A13, A31, A33. Similarly, so we'll come to the third element. Third element is A23. It's multiplied by minus, that is minus A23 of. So A23 is an element of second row third column. What are the element of second row third columns are get neglected, and the remaining elements are nothing but A11, A12, A31, A32. So then all the terms can be expanded in terms of 2 cross 2 determinants. After then by using the condition of 2 cross 2 get simplified. So product of left to diagonal A12, A33 minus right to diagonal A32, A13. Similarly second element is plus A22 of. Product of left to diagonal is A11, A33 minus right diagonal is A13, A31. Third one minus A23 of. Left diagonal is A11, A32 minus A31, A12. So gets multiply. Minus A21, A12, A33. Minus into minus is plus. A21, A32, A13. Then second group plus A22, A11, A33. Plus into minus is minus. A22, A13, A31. Minus third group A23, A11, A32. After that minus into minus is plus. A23, A31, A12, and let be called as an equation 2. So comparing in equation 1 and 2, both are will be equal or not. But each and every terms are comparing with each other. Now the first element minus A21, A12, A33. So can be comparing. Listen here, A12. A21, A33, including sign, plus will be plus or minus it will be minus, both are will be equal. So that is first elements are equating with each other. Similarly, next element A21, A32, A13, A21, A21, A32, A13. That one. A13, A21, A32. It will be equal to each other. Similarly, third element, A22, A11, A33, A11, A22, A33, positive, positive. Then fourth element, minus A22, A13, A31. Then the last element, minus A13, A22, A31. The next element, that is also completed. Next element, minus A21, A11, A32. So minus A11, A23, A32. That's also will be equal. And the last element, A23, A31, A12. That is also equal to each other. Therefore, each and every terms of equation 1 and 2 are comparing with each other. So both are will be equal. It means either it can be using in the row, first row, or in the first column. The values of the determinants are always same. Therefore, it can be using in either any one of the rows or any one of the columns can be along with their expansion. Now, ಯಾವ row use ಮಾಡಿದ್ರು ಆಗುತ್ತೆ, ಯಾವ column use ಮಾಡಿದ್ರು ಆಗುತ್ತೆ. That values is always nothing but same. But usually, the first is always depends on the first row because simplification is nothing but same. So, common element to simplification easy ಆಗಿ ಬರೋದ್ರಿಂದ ನಾವು ಫಸ್ಟ್ ರೋನ ಮ್ಯಾಕ್ಸಿಮಮ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸಿಂಗ್ ಇನ್ ಎನಿ ಒನ್ ಆಫ್ ದಮ್. ನೀವು ಯಾವ ರೋನಲ್ಲಿ ಯಾವ ಕಾಲಮಲ್ಲಿ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿದ್ರು ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಡಸ್ ನಾಟ್ ಆಲ್ಟರ್ಡ್. So next we'll discuss some 3x3 determinants or it will be matrix. So if the values or elements of the matrix either it can be given as either in matrix form or in determinant form. Suppose if it is a matrix form, the headings are given as find the value of determinants. Otherwise in determinant form, either it will be simplify or it will be evaluate. So problem alle already determinant formation alli irutte anadadre ಸೊ ಇವ್ಯಾಲ್ಯೂಯೇಟ್ ಅಂತನೋ ಅಥವಾ ಸಿಂಪ್ಲಿಫಿಕೇಷನ್ ಅಂತನೋ ಕೇಳ್ಬೋದು. ಅಥವಾ ಮ್ಯಾಟ್ರಿಕ್ಸಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಫೈಂಡ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ಅಂತ ಇರುತ್ತೆ. ಸೊ ದೆನ್ ವಿಲ್ ಅಬ್ಸರ್ವ್. ಸೊ ಫಸ್ಟ್ ವಿಲ್ ದಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ ಐದರ್ ಡೆಲ್ಟಾ ಆರ್ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಎ. ಎನಿ ಒನ್ ಆಫ್ ದಿ ಸಿಂಬಲ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸಿಂಗ್. ದ ಫಸ್ಟ್ ವಿಲ್ ರೈಟ್ ವಾಟ್ ಆರ್ ಇನ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಟ್. 1, 2, 3, -1, 4, 0. 4, 1, 0. And it can be choosing for any one row or any one columns after that along that expansion. ಸೊ ನೀವು ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಯೂಸ್ ಮಾಡಿ, ಎನಿ ಒನ್ ಆಫ್ ದಿ ರೋ ಆರ್ ಎನಿ ಒನ್ ಆಫ್ ದಿ ಕಾಲಮ್. ಬಟ್ ಯೂಶ್ವಲಿ ಫಸ್ಟ್ ರೋನ ನೀವು ಯೂಸ್ ಮಾಡೋದಾದರೆ ಸಿಂಪ್ಲಿಫಿಕೇಷನ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ಇನ್ ಫಸ್ಟ್ ರೋ ನಾನೀಗ ಇಲ್ಲಿ ಫಸ್ಟ್ ರೋನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇನ್ ಫಸ್ಟ್ ರೋ ಅಕಾರ್ಡಿಂಗ್ ಟು ದರ್ ಸೈನ್, ವಾಟ್ ಆರ್ ದಿ ಮಲ್ಟಿಪಲ್ ಸೈನ್ ಆಫ್ ದಿ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್, ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿ ಸೈನ್ ದೀಸ್ ಆರ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್. ಸಪೋಸ್ ವಿ ಕ್ಯಾನ್ ಬಿ ಚೂಸಿಂಗ್ ಫಾರ್ ಸೆಕೆಂಡ್ ರೋ. ನಾವೇನಾದ್ರು ಸೆಕೆಂಡ್ ರೋನ ಚೂಸ್ ಮಾಡಿದ್ರೆ ದ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಮೈನಸ್ plus minus, as in third row plus minus plus. Similarly for the first column plus minus plus, second column minus plus minus, third column plus minus plus. So any one of them will be choosing. ನಾನು ಈಗ ಇಲ್ಲಿ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡ್ತಾ ಇರೋದು along the first row. So in first row first element 1. So 1 into plus into 1 is nothing but 1. After that, so 1 is an element of first row and first column. These elements are get neglected. ಥರ ಒಂದು ಸ್ವಲ್ಪ ಡಾಟ್ಸಲ್ಲಿ ಸಿಂಬಲ್ಸ್ ನೀವೇ ಡಿನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಬೇಡ. ಸೊ ವಾಟ್ ಆರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದರೆ 1 ಯಾವ ರೋನಲ್ಲಿ ಯಾವ ಕಾಲಮ್ಸಲ್ಲಿ ಇರುತ್ತೆ, ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಗೆಟ್ ನೆಗ್ಲೆಕ್ಟೆಡ್. ಸೊ ವಾಟ್ ಆರ್ ದಿ ರಿಮೈನಿಂಗ್ ಎಲಿಮೆಂಟ್ 4, 0, 1, 0 ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ 2x2 determinants. Similarly, next element is plus 2. After that multiple of symbol is minus. Plus into minus is -2 half. So 2 is an element of first row and second column. 2 is an element of first row, second column. Therefore these elements are get neglected. What are the elements of that row and columns are get neglected? So what about the remaining? -1, 0, 4, 0. These are the elements of the 2x2 determinants. -1, 0, 4, 0. So similarly third one. So third one is nothing but +3. So 3 is an element of the first row, second last column, first row, third column, and again these elements are get neglected. Remainings are nothing but -1, 4, 4, 1. minus 1, 4, 4, 1. These are some elements. So after that, by using the simplification for the 2 cross 2 matrices. So 2 cross 2 determinant means first will product of left diagonal minus right diagonal. So left diagonals are 4 into 0 is nothing but 0 minus right diagonals are 1 into 0 is 0. Similarly, next element is minus 2. Again, product of left diagonal minus 1 into 0 is 0 minus right diagonal is also 0. Then third element plus 3 of left diagonal is minus 1 minus right diagonal is 16. 4 4s are 16. So get simplify. 0 minus 0 is 0. 0 into 1 is 0. Again 0 minus 0 is 0. 2 into 0 is 0. Plus 3 of minus 1 minus 16 is nothing but minus 17. So after that 0 minus 0 plus into minus is minus 3 into 17. That is the value of that determinant. So minus 51 is the value of that determinant. Similarly, for the next problem, 2 is equal, second problem is nothing but elements are 3, minus 4, 5, 0, minus 1, minus 2, 2, 3, 1. So first will denoted by either it will be delta or determinant of A. Now first element will be choosing for again first row. So first elements are multiplied by alternating sign, plus minus plus. 3 of, again 3 is an elements of the first row, first column. These elements are get neglected. Remainings are minus 1, minus 2, 3, 1. Then second element is minus 4. After that multiplied by its another one of the minus is plus. Minus into minus is plus 4 of. 4 is an element of second column, first row. These elements are get neglected. Minus 4 is an element of the first column and first row. Second columns are get neglected. What are the remaining element? 0, minus 2, 2, 1. And third element is 5. 5 is an element of the first row, third column. 5 is an element of first row, third column, and those elements are get neglected, and the remainings are 0, minus 1, 2, 3. 0, minus 1, 2, 3. So get simplify. 3 of. First will product of left diagonal. Minus 1 into 1 is minus 1. Minus right diagonal. 2 into minus 2 is minus 6. That is minus of minus 6. But already one minus elements barta. So innone negative irodu according to the results or formula. Similarly, fourth one, 4 of. Left diagonals are 0. Minus right diagonals are minus 2 into 2 is minus 4. Then last element, 5 of. Left diagonal is 0. Minus right diagonal is minus 2. So after that 3 of minus 1, minus into minus is plus 6. Plus 6 minus 1 is 5. 4 of 0 minus into minus is plus 4. Plus 5 of 0 minus of minus 2 is plus 2. So 5 3s are 15. 4 4s are 16, 5 2s are 10. 15 plus 16 is 31, 31 plus 10 is 41. So that is the value of that determinant. So similarly for the third problems. So third problem is 0 1 5, 2 minus 3 1, 5 0 6. Again first if it is denoted by either determinant of A, otherwise delta. So again by using the first row, otherwise will be changes, some changes will be taken. So will be considered for the first column plus minus plus. But first two problems ನಾನು row wise ಅಲ್ಲಿ expand ಮಾಡಿದ್ದೀನಿ. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪಾಂಡ್ ವಿತ್ ಸಮ್ ಅನದರ್ಸ್. ಫಸ್ಟ್ ಕಾಲಮಲ್ಲೇ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ ನೋಡಿ ಇಲ್ಲಿ. ಫಸ್ಟ್ ಕಾಲಮ್ಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಗೆಟ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಆಲ್ಟರ್ನೇಟಿವ್ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್. ಅಗೈನ್ 0 is the first element. So get neglected. What are the elements of 0 are represented in which rows and which columns? 0 rows and columns na elements na neglect ಮಾಡಿ. What are the remaining? -3, 1, 0, 6. ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ಸ್ ಕಾಲಮಿಗೆ ಬನ್ನಿ. ರೋ ವೈಸ್ ಹೋಗ್ತಾ ಇಲ್ಲ ನಾನು, ಕಾಲಮ್ಸಲ್ಲಿ. ಸೊ -2. So -2 is an element of first column, second row. -2 is an element of first column, second row. So and again these elements are get neglected. Remaining is nothing but 1506. 1506. And third element is 5. 5 is an element of first column, third row. Again these elements are get neglected and the remainings are 1, 5, -3, 1. So get simplify. 0 of, what are the product of left diagonal? -3 into 6 is -18, minus right diagonal is 0. Second element is -2 of, left diagonal is 6, minus right diagonal is 0. And 5 of, left diagonal is 1, minus right diagonal is -15, minus into minus is nothing but +15. So 0 of -18, -2 of 6 minus 0 is 6, plus 5 of 5 plus 15 plus 1 is 16. 0 into 18 is 0, 2 into 6 is 12, 16 into 5. So get subtraction. -12 plus 18 is nothing more, 68. So that is the values of that determinants. So it's also can be, once we'll try with either in column wise or in other row wise, the values is again nothing but same. ನಾನೀಗ ಫಸ್ಟ್ ಕಾಲಮ್ನ ಯೂಸ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಿ ತೋರಿಸಿದ್ದೀನಿ. ನೀವು ಅದನ್ನೇ ಫಸ್ಟ್ ರೋನಲ್ಲೇ ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಫಾರ್ ದಿ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್. ಈಗ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ನ ಯಾವ ಥರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ದೀವೋ ಅದೇ ಥರ ಫಸ್ಟ್ ರೋನಲ್ಲೇ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ನೋಡಿ, ಸೇಮ್ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ನೀವು ಯಾವ ಕಾಲಮ್ಸು ಯಾವ ರೋಸ್ ಬೇಕಾದರೂ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಸೊ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ ಅಂದರೆ ಇಟ್ಸ್ ಓನ್ಲಿ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ಫಸ್ಟ್ ರೋ. ಅದರನ್ನೆಲ್ಲ ಡಿಪೆಂಡ್ ಮಾಡಲೇಬೇಕು ಅಂತಿಲ್ಲ. ಸೊ ಯಾವ್ದಾದ್ರು ಒಂದು ರೋನ್ ಮೇಲೆ ಅದನ್ನು ಡಿಪೆಂಡ್ಸ್ ಮಾಡಿ.